Hello, so today we are talking about chi-squared significance tests, and we're talking about the third and final test that we have, and that's the test for association. It's also called the test for independence. So let's take a look at what that looks like. Just to recap, there are three types of chi-squared tests. Goodness of fit, we've done, that was with a one-way table, and we are comparing categories within one distribution. And this is like the M&M's example. So we had a one-way table. We were comparing categories or different colors within one bag of M&M's. The second test that we did was homogeneity. So homogeneity tests a single categorical variable against different populations. So I took a sample from one population and then a sample from another population with homogeneity. So I was asking one question to distinct populations, and an example of that is comparing TV show preference or political party within two genders. So I interviewed the men, then I interviewed the women, and I asked them the same question. Well, what if I want to compare multiple variables within one population? So what if I want to just take one sample and from that one sample look at a couple different things and ask a couple different questions? So that's the chi-square test of association. So the goal is we want to know, is there significant association between two categorical variables? So I'm looking at two variables within one population, or just taking one sample and then breaking it down. So we're going to take a look at an example here in a minute, but I'm going to explain or kind of review something. Maybe you've heard of it before. It's called exclusive territory. So exclusive territory is a law or is an act that's in place for franchises. So Chipotle is a franchise, Chick-fil-A is a franchise, UPS store, Cookout down south, they have delicious milkshakes. So these are franchises, which means I can apply to open one. Well, if I open a Chipotle, I don't want someone else opening a Chipotle down the street from me. I want to make sure there's a good distance between my Chipotle or my Chick-fil-A and the next Chick-fil-A or the next Chipotle. So the rule that helps prevent two of the same stores opening up next door to each other is called exclusive territory. So with that understanding or with that badge, let's take a look at this example. It says, suppose Fortune 500 took a SRS of 170 new franchise firms, so people who just opened their own Chick-fil-A or opened their own Chipotle. From the sample, they measured the number of successes after 3 years of opening, so they looked and saw was the company still in business, and researched whether or not it was under exclusive territory, meaning whether or not it had the rule that no one else could put the same store nearby. The results are in the table below. So you see we have the exclusive territory. So was it under exclusive territory is my column. And then you can see, yes, it was under exclusive territory. No, it was not under exclusive territory. But then we also have that did they have success category. So yes, they were still in business, or no, they were not still in business. So they took a sample of 500 and then broke it down into this table. Well, we want to test if being in exclusive territory explains the success of a franchise. Or if you're in exclusive territory, do you have success? So is there an association or relationship between being in this column and having success overall? So in order to do this, I need to conduct a significance test, and I have to go through all 4 steps. So you should be getting really familiar with these 4 steps by now. The state step, population, parameter, and my 2 hypotheses, and we're going to talk about what these look like for independence or association. Plan, random samples every time. Also, the expected counts have to be greater than 5. This is consistent with all chi-squared tests. Calculations, I need chi-squared, degrees of freedom, and the p-value. I have to show my substitution, like you'll see today, even if I use a calculator, I have to show this substitution. And then my conclusion, reject or fail to reject, p-value, and reference the problem. So let's start with my state step, the hypotheses. I have to state my hypotheses, and for the test of association, we have a couple different ways of wording things. The first one is in blue. The null hypothesis is there is no association between the two variables or two categories, meaning there's no kind of relationship between one and the other. The alternative is that there is an association between the two categories, meaning they are related, there is a connection, there is a reason that the second happens given the first. Other ways of stating the hypotheses are to use the word related. So the two categorical variables are not related is the null. The alternative is that they are related. And then the third way, of phrasing things is the two categorical variables are independent from each other is the null. So independent means that they're not related. One does not impact the other. They're not associated. The alternative is that they are dependent, or that they are related, or they are associated. So you can choose which of these three wordings makes the most sense to you or that you prefer, and just stick with it. So let's keep going with my problem. The state step, the population, well, they took a sample of new franchise firms, so the population is all new franchise firms. And the parameter, or what we're trying to measure, is we want to test a claim about the relationship between exclusive territory and success. So if I write that out, it would look like, so we want to test a claim about exclusive territory and company success. Well, then I can write my null hypothesis. My null hypothesis is that there is no relation or no association between exclusive territory and success. So that's the null. Remember, null means zero, they're equal, there's no association. The alternative is that there is an association between exclusive territory and success. So these are my two hypotheses. The null is the no difference, no association. The alternative is that there is an association, and I'm going to complete the test to see if I can reject this claim. So we're going to go to the plan step. The first step is random. Well, in the problem, it says that it took a simple random sample of 170 new firms, so random is check. The second thing I have to check are the expected counts greater than 5. Well, if you remember from class and from the last video, expected counts, we do the row total times the column total divided by the total, which we call n. So if I think about this, for my first box, the yes and the yes box, if I do the row total, that would be 123 times the column total of 142 divided by the total of 170, and that gives me 102.74. Now I can keep going and checking my expected counts. For example, if I wanted to do this box right here, this no and yes box, I would do 47 times 142 divided by 170, and that would give me 39.26. And then if I were to keep going, I would get these two values right here. So I did my 4 expected counts. I have them color-coded. So the blue, the red, the purple, and the green all correspond. And if I look at these totals, they're all bigger than 5. So I know that that condition is met as well. So usually from here, we would take the observed minus the expected squared divided by the expected and add them all up for chi-squared. You can do that every single time and you're going to get the perfect answer, but you can also use your calculator. So pause the video, get out your calculator, and get ready to follow along with these steps. So the first step is we're going to enter all of our data into a matrix in the calculator. So you may be familiar with this from Algebra 2 or pre-calculus or another math before. So to do this, you're going to press second, then the X minus 1 button, and use the left arrow to get to the edit screen, and then press enter on matrix A. And here, so in matrix A, you're going to enter the number of rows and columns for your matrix. So for us, we have a 2 by 2 matrix because we had 2 rows and 2 columns in our data set. So you're going to enter your data as shown above or make it match your table. So if this is a 2 by 3, we're going to cross out that row and you're going to want to enter your data or your numbers in something like this so they match your rows. Once you have your data stored in a matrix, then you can run the chi-squared test on it. So you'll press stat, then test, scroll down to chi-squared test, and when you press enter, you're going to get to this screen, and it's going to say chi-squared test, observed, expected, and calculate. Your calculator automatically knows that you put the observed or put your data in matrix A, and it's going to give you the expected counts in matrix B. So all you do is type in your observed in A, make B say the little parentheses with a B, and then press calculate. And when you do that, it's going to give you your p-value, your chi-squared value, and your degrees of freedom. So it's a pretty magical tool that your calculator gives you. Chi-squared, the value it should give you is 5.911, and the p-value it gives you is 0.015. If we draw my curve, what that's going to look like is my chi-squared is down here at 5.911, and then the p-value, or the little area shaded up here, is 0.015. My degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So degrees of freedom would be 2 minus 1 times 2 minus 1, and that's going to give me 1. So I have 1 degree of freedom, and I know my chi-squared is 5.911. So if you did this using the formula we've used the past 4 classes, and you found your degrees of freedom, you could use your table to find your chi-square value. If I have 1 degree of freedom, I'm looking in this top row, and I'm trying to see where is my chi-squared value in relation to that row. Well, 5.9 is going to be right in between here. So I know my p-value is going to be in between 0.2 and 0.1. So my p-value is less than 0.02, but bigger than 0.01. So if you don't have a calculator or you forget how to do that test in it, find the chi-squared value using the formula we've been using, O minus E squared divided by E, and doing the sum of those, so adding those up, and then using this table to find your p-value. So I know my chi-squared is 5.91, which is in between those two values, meaning my p-value is going to be in between 2% and 1%. They're somewhere in between there. So for the conclude, it says, is there evidence that there's a difference at the 5% significance level? Well, if alpha is 0.05, and I know that my p-value is 0.015, my p-value is less than alpha. So, since the p-value is less than alpha, and we can say 0.015 is less than 0.05, we can reject the null hypothesis Well, what was the null hypothesis? The null hypothesis was that there was no association between exclusive territory and success. So I can reject the null hypothesis that there is no association between exclusive territory and success. So essentially I'm saying there is a relationship, there is an association. In this conclusion, when I reject the fact that there's no association, I'm in turn saying it does matter. If you're in exclusive territory, you're more likely to be successful. That's what this conclusion is saying. And I say that by rejecting the claim that there's no association. So that's a wrap. We use chi-squared test for association to determine if there's a relationship between two categorical variables. Our calculator is a tool that helps us find chi-squared using the matrix function. You do not have to use your calculator, but it is a nice tool to have. So use it on your homework, experiment with it, make sure you're comfortable with it, and come to class with questions so we can go over it. Thanks, and I'll see you next time.